Hello, I'm Clarence Rice, and today I'm going to be doing a home lab experiment on how to make a homemade battery using simple foods that you can find in your cupboard in your refrigerator, and I'll be seeing if we can get any voltage out of it. Basically, we all know that batteries generate electricity, and what happens and how a battery generates electricity is that it has two electrodes and an electrolyte. And that's what allows the current to flow through. I'm going to see if the juice in a potato will provide enough electricity to get a readout on my multimeter, and I'll be using a copper wire and a galvanized nail to do so. So the big question is will I get enough voltage to get a readout on my multimeter? Now, some materials that I need to perform this lab is I need your typical multimeter. I need a knife so I can cut my fruit. Copper wire. I have 4 copper wires. I have 4 nails. I have 3 alligator clips with a wire. I had to make these myself, so I hope they work. And then I've got a lemon, an orange, and a potato to help do this experiment. So the first thing that we are going to do is we're going to cut a potato in half. And then a lot of people don't realize, but potatoes are quite really juicy in that. We're only going to use 1 potato for right now though. And then what you want to do is very easily, you want to put a slit in the potato because this is where you're going to put the copper wire. Now make sure, one thing to make sure of is when you're putting your copper wire and your nail in the potato that you don't touch the two, because basically they'll short each other out and you're not going to get a reading. And you just put the copper wire and then a nail in there. Now I'm going to turn on, I don't think I'm missing anything, I'm going to turn on my voltmeter, or my multimeter, I'm sorry. Then I'm going to see if I can get a readout. And I have, can you please zoom in on this? I have 0.85 volts out of this potato. So did we get enough electricity out of this potato for a battery? Yes. Will it be able to do anything? No. And because the minimum you need to light up any type of LED is 1.5 volts. So what I want to do now is I want to take this potato, I'm going to write down 0.85 volts for the potato. Now let's see what we will get out of an orange. And again, you're going to make your slit, whatever you want to call it. It's a good thing these people know me. Oh, that's real juicy. There. Now, let's see what we have. Let's see how many voltage we can get out of an orange. Wow, 0.98 out of an orange. So what that tells me now is if we have 0.98 out of the orange, we've got 1.83 volts between these 2 batteries that would be enough to light up an LED if I had a light bulb for this tool. This is what I had planned on, seeing the light bulb work. Unfortunately, we're not going to be able to because I don't have a light bulb for it. So that kind of stinks. So what we're going to do now is do a 3rd battery, and we're going to use a lemon. .98 out of an orange. I would have never, I guess I don't understand. Really? There it goes. Okay. Now we're going to get a readout on the lemon and see what the lemon puts out. .98. It's fluctuating, but it could be me moving around. But we did see .98, right? Well. So, in reality, we've got a potato, an orange, and a lemon, and we all know that they have a potato has phosphoric acid in it. We also know that orange and lemons have nitrous acid, something like that. So with that said, obviously you would think that the orange and the lemon would have more acid in it, which results in a higher voltage that we got for the readout of the multimeter. Now, one last thing I would like to do is put these all in connection. I'd like to put these in a series to see if we can get, I said 0.95 for the lemon. So, just my rational thinking that with the voltage that we got from the potato, the orange, and the lemon, we should get upwards of about 2.5 to 2 3/4 volts out of these three items when we put them all in a series. So when we put them in a series, it's very important that we're going to clip onto the potatoes copper wire, and then the oranges, nail. Then we're going to go from the orange's copper wire to the lemon's nail. Now these are now considered to be in series. So what I should be able to do is get a readout when we touch 2.83 volts is what we ended up getting when we put the potato, the orange, and the lemon in a series. So, with that said, we have just made an electrochemical battery. Basically, chemical energy was converted to electric energy by electron transfer. Phosphoric energy in the potato allows the flow from the nail and the copper wire. And we already talked about the nitric acid in the orange and the lemon that allows the flow between the nail and the copper wire. And then when we put them in series, it just goes to show that we ended up getting 2.83 volts. When I added them up individually, it showed about 2.78 volts. If I had an LED light, it would turn on right now. However, I don't. All I have is the proof with the multimeter when I put these in series to show the 2.83 volts. Anyway, so my conclusion is you can take, if you have the simple tools of a multimeter, if you have some copper wire, if you have some alligator clips and some nails, you can actually test other types of foods that you can find in your house, like tomatoes, peppers, whatever is juicy, to allow the current to flow between the copper wire and the nail to get the readout on your multimeter, and thus you could possibly light up an LED. But you got to remember, you got to get a minimum of 1.5 volts for that to happen in the first place. So with that said, that will conclude this lab experiment. If you have any questions, please don't hesitate to ask. Thank you.